Hi all, welcome to RN Tutorials. So in this video we are going to discuss how to find out center of gravity of a given figure. That means solving a problem. So here the problem is given like this: find the center of gravity of 100 mm by 150 mm by 30 mm T section size. Okay, so that means for T shape we are going to find out the center of gravity. So as we know that it is the method similar to finding the centroid as it coincides with the center of gravity. So we follow the same area method for finding the center of gravity. So this is the T section which is given in the problem. I want to represent like this, and which is symmetrical about y-axis here. Here the shape is symmetrical. T section is symmetric section, so which is symmetrical about y-axis, and the dimensions are given as 150 height and 100 mm width and 30 mm thickness. Okay, so with these dimensions we have to find out the center of gravity. Already we know that if it is symmetrical about y-axis, the x component becomes 0, and y component we need to find out here. Okay, for the center of gravity. So for that I want to divide the T shape into two convenient parts. Two, that means into two rectangle shapes like ABCD. Already I have represented here. And next I want to take the, this is flange here, top part is flange, and this is the web. Both are in the shape of rectangle. So ABCD one shape and EFGH another shape. Okay, for these two shapes we need to find out area and the y components for finding the y component of the center of gravity of this T section. Okay, so first I want to take the area ABCD. So for this ABCD area I want to write the area A1, which is length into breadth. Okay, so length is 100 mm and breadth is already the which is wedge breadth is given as 30, so automatically this breadth also becomes 30 only, so 100 into 30, so which will give you the area of the shape ABCD. Okay, which is 3000 mm square, as we have taken the values in millimeters. Okay, and now I want to write the y component. So y components for this ABCD figure, ABCD shape, that means the center of gravity position along the y-axis. Okay, from the base to the center midpoint location of this area, which is the center of gravity for this ABCD, which is a divided part. Okay, so how to write means y1 is equal to, the total height is 150. Okay, take 150. 150 minus the middle point means here what is the height of this flange, that is equal to 30. So half of the 30 means we need to take 30 by 2. Okay, when you subtract this 30 by 2 from 150, we will be getting the middle point, that is the center of gravity position for this particular area ABCD. So which is equal to 150 minus 15. So which will give you again 135 mm, which is the y component for the area ABCD, which is the center position of the ABCD area. So next we go for another area, which is EFGH area. So for this also we need to write the area 2 for EFGH part. So again length into breadth we need to apply. So the total height is 150. We have to know up to FG height. So FG height can be obtained by 150 minus what is the 30 is the breadth of the flange. We have to subtract. So 150 minus 30 will give you 120 only. So 120 into breadth. Okay, that is width of the flange. Sorry, width of the web, that is EFGH we have to take, which is equal to 30. So 120 into 30, so which will give you again the area as 3600 mm square. Similarly, we need to write the y component, which is the distance along the y axis, that is symmetrical axis, from the base. Okay, now the total height is 150, and again 150 minus 150 minus 30 will give you 120. So FG height is 120, so half of the this height will give you the center of gravity, that is the center position of this particular area. So 120 by 2, which is equal to 60 mm. Okay, so this is the area and the y component for the second area. Okay, so next I want to write all the values whatever we got, a1 y1 and a2 y2. Next I want to take the formula for finding the y coordinate for finding the center of gravity position. Okay, so y bar is equal to, we know the area method formula is a1 y1 plus a2 y2 by sum of the areas a1 plus a2. So substitute all the values. A1 means here 3000, and into y1 means 135, and plus a2 means 3600 into y2 means 60. So by sum of the two areas is 3000 plus 3600. So by simplifying this equation, we'll be getting the y component of the center of gravity for this T section as 94.1 mm. So which is the y coordinate. The final answer we need to get as x component is 0. Okay. So here on the diagram we can represent on the y-axis, because of symmetrical about y-axis, we will be getting the point on the y-axis only. Okay, I want to represent the center of gravity position like by taking the 94.1 mm as the distance. So like this we can represent on the diagram by assuming a particular distance on the y-axis. Okay, this is a way of finding the center of gravity of given plane figure by using the area method, which is similar to the centroid method. Okay, I hope you understand how to find the center of gravity of a given plane figure, the simplest method of area method. So that's it. Thanks for watching video. Thanks for watching my video, and please subscribe to my channel and share my videos with your friends. And if you have any doubts, please feel free to mention that doubt in a comment section so that I'll try to clarify your doubts. And once again, thank you all.